This time, let's talk about the quadratic formula. This formula allows us to determine or solve the roots of any type of quadratic equation, whether it's complete or incomplete, or whether it's factorable or not, or for situations where the value of a is no longer 1, we can still solve for the roots of quadratic equation with ease. Now, of course, we have other methods, extracting square roots, factoring, and completing the square, but this quadratic formula is designed to solve all types of quadratic equation. Now, I'm not going to share here the derivation of this formula. We have a separate video for that on our channel, but let's just automatically proceed to the formula itself. The formula is designed in this manner. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Take note that for a quadratic equation, there is a maximum of 2 roots. That is why, in this case, we are considering plus and minus. Hence, there are 2 possible values here. X sub 1 probably taking the positive, and x sub 2 taking the subtraction or the difference of our numerators. Now, aside from that, I would like you to notice this one here. Inside our radical expression or our radicand, that's actually our discriminant. The thing that we learned before in determining the type of roots is what we call a discriminant. Take note that if b squared minus 4ac, the discriminant is greater than 0, then we are expecting to have 2 roots that are real and unequal. If this is 0, that will mean this expression, plus minus 0, will no longer affect on our equation. Hence, we only have 1 root. And if this is negative, b squared minus 4ac is negative, and square root of a negative number is an imaginary. Hence, the roots are imaginary as a whole. Okay, this is just in a connection with the discriminant discussed earlier. Now let's talk about this given quadratic equation. X squared plus 3x minus 10 equal to 0. Now we can use other methods in solving for these roots, but let's try to use the quadratic formula in this case. Of course, we know that a is 1, b is 3, and c is negative 10. Plug in that on our equation, we'll have this one here. And of course, simply simplify first the radicand or the radicand expression. You will have here x is equal to negative 3 plus minus square root of 49 all over 2. And since 49 is a perfect square number, and even if it's not, we are expecting to have 2 possible answers here. But in this case, we have minus 3 plus minus 7 all over 2. Let's take the plus for our x sub 1. So negative 3 plus 7 is positive 4 over 2. And let's take the subtraction for our x sub 2. Negative 3 minus 7 is negative 10 all over 2. Simplifying them, our roots for this quadratic equation using the quadratic formula are 2 and negative 5. Let's just try to check whether we can look for other methods and still get 2 and negative 5. We know that x squared plus 3x minus 10 equal to 0 is factorable. Hence, we can use factoring here, and we can have the factors x plus 5 and x minus 2 equal to 0. And according to the zero factor or zero product property, we can break them into 2 separate items. X plus 5 equals 0 and x minus 2 equal to 0. So our first root is negative 5 and our second root is 2, which are actually just the same as the roots presented earlier. So this is the proof that our quadratic formula will still guarantee to get the correct and the same roots as other methods. Now we are going to use this, and because this is easier and true for all. Please try to visit our channel for the derivation of this formula at the same time with the practices and demonstrations for this type of concept.